All right, hey guys, we're going to take notes on page 4. Make sure you write your name up here in the corner. And we're going to take notes on separating mixtures. Okay, so first, before we start, make sure you have a pencil, a highlighter, and this piece of paper in front of you. If you don't, pause and go get them. Okay, so let's talk about inter and intramolecular forces. So two kinds of attractions operate within or between molecules. So intramolecular forces hold atoms together within a molecule. Okay, these are also known as bonds. We call these bonds. Intermolecular forces are when the molecules are interacting with each other. That's how I remember. They exist between the molecules themselves. Okay. So an intramolecular force, you have ionic bonds and covalent bonds. And we're going to talk more about this in, I think, not our next unit, but the unit after that. And intermolecular forces, these are abbreviated IMFs. If you ever see IMF, it's talking about intermolecular forces. These are not as strong as bonds. Okay, they are weaker. And they determine properties like boiling point, melting point, solubility. Okay, so here's a question. Water has stronger intermolecular forces than alcohol. Which one do you think would have a higher boiling point? Okay, so because water has stronger intermolecular forces, it's going to take more energy to break the water molecules apart from each other. So like here's a water molecule, here's an H2O, here's another H2O. These are the intermolecular forces attracting these two molecules together. They are stronger in water than they would be in alcohol. Therefore, water would have a higher boiling point. Okay, so the stronger the intermolecular forces, the higher the boiling point and melting point. Okay, because it is harder to break the molecules apart. Like I said, if it's harder to break the molecules apart because they're more attracted to each other, it's going to take more energy. That melting point or boiling point is going to be higher. Okay, if substances have similar intermolecular forces, then one can dissolve the other. We call this like dissolves like. And you might hear that as you're taking chemistry classes for the rest of your high school and college. Like dissolves like. And what that means is that polar things dissolve polar things, non-polar things dissolve non-polar things. So water can dissolve alcohol. Water cannot dissolve oil. And the reason why is because water is a polar molecule. Now, right now, you don't need to know exactly what that means. We'll talk about that in a couple months. And oil is nonpolar. What you need to know, though, is that the reason they don't mix is because they're not alike. One is polar, one's nonpolar. That's why they don't mix. Okay, so when things don't mix, they make suspensions, right? When they don't dissolve, they make suspensions instead of solutions. They make heterogeneous mixtures. So there are all these different methods we can use for separating out the parts of a mixture. If you have a mixture, you want to separate the parts out, okay? First thing you can do, depending on what sort of mixture you have, is separation using a magnet. Okay, separation using a magnet. A magnet can be used to separate a magnetic substance from a non-magnetic substance. Like, for example, if you had iron mixed with sand and you want to get the iron out, you stick a magnet in there, you can pull the iron out from the sand. Okay. The next method is decantation. Decantation or decanting. Okay. Maybe your parents have a decanter at home. Decantation is removing a layer of liquid by pouring it out. Pouring it out. Okay, it can be used when two substances are immiscible. Immiscible means that they can't mix together, so they can't mix. That's what immiscible means. Like oil and water, those are immiscible. You can mix, you can try to mix them up, but they will just separate again, okay? If things have different densities. So like here's an example. Here's a mixture. It looks like you have the two components are separated. One's on the bottom, one's on top. They can decant it, meaning they can just pour out the top layer until it's all gone. Okay, so that's decanting. The next method is using a centrifuge, centrifugation. Okay, a centrifuge is a machine that spins very rapidly. It's kind of like, think about a washing machine. You put your clothes in your washing machine, and when it's done with the cycle, it spins it really, really fast, and that spins all the water out, right? Same concept. So if you were, and you use this a lot when you get to college chemistry, and I think you'll probably use it maybe if you take like honors or AP biology or chemistry next year. Okay, so if you have a suspension that you want to separate, you take it in the test tube, you put it inside the centrifuge, it spins around, and it forces the heavier objects to the bottom. Okay, the materials that are more dense sink to the bottom. That's using a centrifuge. Okay, here's the picture. The next method you can use to separate mixtures is filtration. Filtration separates solids from liquids. Solids from liquids. Okay. A filter, think about like a coffee filter. Same concept. It only lets the fluid pass through, leaving the solid behind. So the filtrate is the fluid that passes through, and it cannot be used on solutions, only on suspensions. Okay? Only on suspensions. For example, something like sand and water. If you had sand mixed with water and you wanted to get the pure water out, you could do filtration. So here's a picture. You have your mixture in here. You put some filter paper in this funnel. You pour it through, and all the water is nice clean water is gonna drip through the filter paper, while the sand will get trapped behind here in the filter paper. Okay, and the water that comes out, that's called your filtrate. Okay, on the back. All right, now if you're separating, so these were all separating suspensions. I want to point that out. This is how you separate suspensions. These now are how you're going to separate solutions. Remember, a solution is homogeneous. A suspension is heterogeneous. Okay? So this is how we separate some homogeneous or homogeneous mixtures or solutions. The first way is through evaporation. Evaporation meaning boiling. It can be used to separate a solid solute from a solvent. For example, salt and water. If you took some salt water and you boiled it, all the water would evaporate off and you'd be left with salt in the bottom, pure salt in the bottom. Now, distillation is a more sophisticated form of evaporation. So it's evaporation, but you've got this fancy setup going along with it. Distillation separates liquids, or I mean, technically you could separate a solid from a liquid, but typically it's used to separate different liquids based on their different boiling points. Boiling points. It's used to purify liquids. So for example, if you've ever heard of like a distillery where they distill different like alcohol things, like I think whiskey is a distilled beverage. What they do is, I mean, I don't know all the ins and outs of it, but basically the concept of distilling is you have this mixture in here, right, with two different liquids, and they have different boiling points. So you heat it up, and once it gets to the first one's boiling point, so like alcohol has a lower boiling point than water. So it would boil first, and as it would boil, it would turn into a gas, and it would come up here, and that gas will travel down this tube. Now, as it goes down this tube, it cools off because it's getting further from the flame, right? It cools off, and as it cools off, it condenses and turns back into a liquid, and it drips as a liquid here. And this is the pure alcohol or whatever it is you're separating. Okay, so that's how they purify that. So here's a practice problem. It says oil companies use distillation to separate different types of fuels and oils from one another. Based on the following approximate boiling points, list the substances in order from weakest to strongest intermolecular forces. So earlier we said that things that have strongest intermolecular forces are going to have highest boiling points. So this one seems to have the highest boiling point. So this one's going to have the strongest intermolecular forces. And this one has the lowest boiling point, so this is going to have the weakest intermolecular forces. So it says from weakest to strongest, so this would be number 1. Then the next highest would be here. So this would be number 2, number 3, number 4, and number 5. Okay. All right. Last thing, chromatography. Chromatography separates fluids based on their solubilities. Chromatography is a way of separating out a mixture of chemicals by letting them creep slowly past another substance. Okay, so let me highlight chromatography. This is our last one. Okay, so a mixture contains compounds A, B, and C. A drop of the mixture goes on a stationary phase. The stationary phase is the thing that stays in place. So for example, a strip of paper, that would be your stationary phase. Now your mobile phase is some sort of solvent like water or acetone or some sort of solvent that's going to travel over the stationary phase. And as the mobile phase moves, this is kind of the key to chromatography. As the mobile phase moves, it separates out onto the components of the stationary phase. Now, the most classic type of chromatography that we see in 8th grade chemistry is paper chromatography. Here is a piece of black ink in a pen. They stick it in the water, and you can see all the colors that make up. So black ink isn't really just made of pure black. It's made up of different colors. Okay. So I'm going to show you a quick little, we're going to try to do a little miniature chromatography experiment here. Here's a strip of paper towel. It's just a paper towel. And I got a washable marker here. And I'm going to make a circle. And now this is black. We're going to see, so this is a mixture, right? This ink is a mixture of different colors. Let's see if it really is black. So I've got a cup of water here. I'm going to just dip it like so. And I'm going to let the water creep up. It's hard for you guys to see, but the water's creeping up towards that black dot. I'm going to leave that there to sit. It's going to creep up towards that black dot. We'll come back to that and we'll see what happens in a second. Let's do the practice problem while we're waiting. It says practice. You run a paper chromatography experiment on black ink. You put the drop of black ink on a strip of paper, put the paper into a container with water in it. You get the results shown at the left. Okay, it says answer the question about the experiment. What's the mobile phase? So this is the same as kind of what we just did. The mobile phase is the thing that moves up. Okay, what's the thing that moves up? It's whatever your solvent is. In this case, it would be water. Water is our mobile phase. That's what's moving up the paper. Stationary phase. What is the stationary phase? The stationary phase is the thing that it is traveling across. So that would be the paper. Your paper or your paper towel is your stationary phase. It says which component is most soluble in the mobile phase. So basically, which one moved the furthest up? Okay, so if this is our origin, if this is our black spot where we started, and we're trying to figure out which is the most soluble or dissolved best in the mobile phase, that would be blue, because that one's the one that traveled the furthest up the paper. Which component has the highest affinity for the stationary phase? That means which one was most attracted and stayed put the best. That would be red. Okay. Okay, let's take a look at our little experiment. It doesn't look exactly like that. I didn't let it sit super long. But this is what we have. Ooh, those colors are kind of hard to see on this camera. You can kind of tell. It's really bright for some reason. I don't know how to fix that. So, maybe if I stand here. Nope. So, it's kind of hard to tell for you guys, but I see some yellows down here. I see some blues around here. So, this is just a really basic chromatography experiment showing that the black ink, it's a mixture of different colors. So it's a mixture of blues and yellows, and I see a little bit of green here. And that is a basic chromatography experiment. Okay? There are different types of chromatography besides just paper chromatography. There's like a whole slew of different types, like gas chromatography and all these different things that they use, especially for things like forensics and stuff like that. But paper chromatography is kind of the most basic. You can do it in your kitchen just like I just did. So yeah, that's pretty much it. Go do the assignment.